morning. Good morning. How are you? Yeah. So we are group 12. I am here by the name of Innocent. My leg number is 223008070. We are going to talk about how can we teach to the dynamics, some concepts and principles. So we are putting emphasis on fiber optic communication system, how it works. So you will be enjoying with another group members. In our presentation, we have here some concepts, objectives, concepts, and principles of electrodynamics, skills needed to teach those concepts, teaching methods and strategies and techniques while teaching these concepts and principles. We will be looking on materials, misconceptions, and we will end up with a summary. So, electrodynamics is a branch of physics which deals with electric and magnetic fields, specifically when they are in motion. We are putting emphasis on fiber optic in our work, which is about the communication of some signals or transmission of those signals in a transmission line is when we want some information to move from one place to another. Here we are going to see about some concepts and principles while in electrodynamics. So we have electric field and electric potential. We have magnetic field. We have electromagnetic waves. We have direct and alternating current, propagation of those electromagnetic waves in different media, and we have also principles, and we are looking about those concepts and the principles which govern those concepts to happen. So we are having Friday and Lenz law. They are somehow connected. We are having Coulom's law, Snell's law, and Fleming's right-hand rule, which goes with Friday and Lenz law in different ways. One determining the direction of the induced current in Friday law, and it is just about that. Then we will come Esther to continue with presentation.
Thank you so much. My name is Warela Esther. With leg number 2230-963. Okay, I'm going to present about fiber optic communication. That's my red number. I'm going to talk about fiber optic communication system. I would like to help me see this video and tell me what you have seen.
With thousands of fiber strands, and a single fiber strand is as thin as a human hair. Optical fibers carry information in the form of light. Let's first learn some fundamental behaviors of light to understand the workings of optical fibers. The speed of light changes when it passes through a medium, and this change in speed is expressed by the refractive index. This variation in the speed of the light leads to another interesting phenomenon, refraction. To understand what it is, let us carry out an interesting experiment. In this experiment, light passes through a prism. You can see that at the interface, the light gets bent instead of going straight. This phenomenon is known as refraction. Refraction occurs when light refraction is the reason why a pencil was bent in a glass of water. This simple refraction technique is effectively used in optical fibers. Now, let's make this experiment a hypothetical one. Using some dopants, we were able to increase the refractive index of the glass in real time. As we increase the refractive index, the light will bend more and more towards the surface. After a time, you can see that the light will pass through the surface of the glass. If we increase the refractive index further, the light will suddenly come back to the first medium as a pure reflection.
Make it total
This is called
internal reflection,
reflection.
which help us in optic fibers communication transmit information.
In this case, at a certain angle called the critical angle, the light will come back to the first medium. This phenomenon of total internal reflection is used in optical fiber cables to transmit the light. The simplest form of optical fiber cable is shown here, cylindrical glass with a high refractive index. If the laser strikes the interface at an angle greater than the critical angle, total internal reflection will
As you
happen,
can see,
and
that
the
is
light
total internal reflection, which is being transmitted as information in that optic fiber. Okay?
This means that light can be confined in the optical fiber over a long distance, no matter what complex shape the fiber forms. Remember, total internal reflection happens between the high refractive index glass and the low refractive index air. However, optical fibers need a protective coating. A protective coating is not possible with this configuration. The introduction of protective material will replace the position of the air and cease the total internal reflection phenomenon. And allow signals to be transmitted attenuation to be able to carry signals.
Okay, we need to
The optical fiber we have just constructed won't be able to carry signals
how
from
information is
fibers.
transmitted as
This
light.
is due to various losses that happen in the cable. This loss of signal strength is generally called attenuation. Absorption and scattering are the main reasons for signal attenuation. This is why you see amplifiers and cables after a certain distance. They boost the signal strength and allow signals to be transmitted over a long distance. The power required for the amplifier is drawn from nearby sources. Now, back to the main topic.
So, can you please tell me what you have got in this video about optic fibers? Anyone? Yes, sir.
Internal reflection.
Thank you so much. What I can say about is fiber optic communication is a method of transmitting information from one place to another by sending pulses of light through optic fiber. I think you have seen that there were a signal like light which was passing through an optic fiber from one place to another. It was going like this one, which is total internal reflection, but it was going in form of light, as you have seen. About principle governing fiber optic system, there are total internal reflection, as you have seen Snell's law. As we know Snell's law, it says that a refractive index of 1 sin theta 1 is equal to n2 sin theta 2. This also helps us in optic fiber communication to know the information which will be transmitted. Another is refractive index differences and numerical aperture. As you can see here, there is a diagram explaining how information are transmitted. I think it's not seen well, but yeah. You can see there is digital input data electric optic converter, and this is an optic fiber cable which will transmit those lights and put it in an amplifier. Then it goes out, and finally we get digital output, which are like Wi-Fi, which help us to transmit messages from one place to another. I would like to continue And we have seen about skills needed to teach fiber optic communication system. As a teacher, you need to firstly understand the content. Okay, you have to know more about fiber optics in order to help students to know or to get some skills about optic fibers. Another is pedagogy. Pedagogy, these are methods you can use to teach in order for students to know more about fiber optics. Another one is assessment. As we know, every teacher has to prepare assessments so as to know if the student have understood what he or she was teaching in order to continue on another content. I would like to invite another person to continue. Thank you.
Thank you. My name is Miguel Emanuel. My leg number is 223018390. So I'm going to continue on the strategies that we can use in order to teach this concept of electrodynamics. There are different strategies that the teacher can use in order to help the student to gain more understanding about this concept. I'm going to start for the first strategies, which is called the concept of visualization. The teacher may use the diagram in order to help the student to gain or to interpret the diagram. For example, on the previous slide, we can see the block diagram for how the optical fibers work. And how the information are transmitted from one place to another. That is, in this way, the teacher uses the diagram. It helps the student to gain more understanding and help them to acquire the skills or more understanding in his way. The second strategy the teacher may use in order to help the learners to may use the simulation, animation, and models. As we see on the previous slide, you see the animations that show how the optical fibers work. This simulation and animation, it is more important to help the learners to get more understandings on the concepts. The third are practical application. Practical application is as a teacher during the teaching session, teacher may give the learners the activities, different activities. Some activities require low order thinking and others require high order thinking in order to help the learners to gain more understanding. So let me stop by here and invite other colleagues to continue. Thank you.
Thank you so much again. I'm going to talk about simulation, animation, and models. As you have seen, my colleague said, simulation, animation, and models can be used to teach fiber optic by a teacher using digital simulation animation to illustrate how fiber optic communication works. For example, show how light signals are transmitted through fiber and how they are converted at the receiving end. As you have seen in our video, there were different materials used to transmit the information, which were simulation and animation. Another one is group discussion. Teacher may use group discussion by dividing his or her student into small groups to discuss about fiber optic communication. Like it says, divide the class into small groups and assign each group specific aspect of fiber optic. The students are provided with tasks to work on regarding the fiber optic communication system. They are divided into groups to discuss about that topic. Another is inquiry-based learning. Here the teacher starts with an open-ended question or real-world problem related to fiber optic communication. For example, how can information can be transmitted, or how messages are delivered from one person to another. Also, this inquiry-based learning can help teacher or students to know more about that topic they are being taught about. Thank you so much. I would like to invite Mama Edo.
Good morning. Good morning. I'm Benigna Itinhai with break number 223027003. I'm going to continue with raw material that can be used while teaching fibers optics communication. First material is optics fibres. Optics fibres, it carries light. It shows how light can travel through thin. Another materials is transparent plastic fibres. Transparent plastic fibres is the largest scale made of fibres. It is used to make the bouncing of light easy for the student to see with their own ears. Another materials is lead torch. Lead torch is the light source. It represents the transmitter. Another materials is faint interactive stimulation. Another materials can be used is YouTube video. The real world context they show how these thin fibers connect interward via massive underwater internet cable. Thank you. Thank you.
Hello. My name is Joseph Ayurasenga, with flag number 22 30 10 904. We are going to continue with how we can deliver that lesson. As we know, we deliver a lesson in a lesson plan, and the lesson delivery is based on 5 E's model, which are first phase is engage phase, where here in that phase you try to attract learners by allowing them to think on how the information can be transmitted from one place to another, and try to think the solution to that way or to that process. The information are being transmitted from one place to another. Here in that phase, you try to allow runner to go through that thinking like how do we send data quickly over long distance, and you allow the learner to go through. The second phase is explore phase. In the explore phase, you allow the learner to sit pairly or in a group and they discuss on the previous question, which are how data can be transmitted, and they share with the siblings. The third one is explain phase. In that phase, the learner are sitting in the learner, they come up with what the findings and share with who all classes or together. And the fourth one is elaborate. Here in that you allow the learner to go through beyond the try how to think on the importance of the application of the optical fiber. Thank you. Let me allow the colleagues to continue.
Hello. Good morning, Gossip.
Good morning.
My name is Gossip David by the reg number 223019694. I'm here as we are talking about the way we can teach this concept. I'm going to talk about the last phase, which is the evaluation or evaluate phase. This phase by this phase of evaluation, as we know, you cannot teach without evaluating what you have taught, if they are already known, if they are already gotten or they are understood. Here, by this phase of evaluation, a teacher or one who is educating must evaluate by assessing whether the concept taught is already gotten as in the goal or objective he has or she has set is set already. Okay, by this evaluation, a teacher can use different assessment tools like quizzes, group works, and so on, where students can have most of time or usually they use it to answer that question or that assessment within the class to verify whether they have understood that concept clearly without going at home to do more drawings. Okay, another thing here is to talk about the misconceptions commonly appear in fiber optic communication system. Usually, it is not as stated there, it is not understandable by everybody that fiber optics works. You know that fiber optics seems like abstract to those one who are not educated. But as it is stated there, fiber optic cable are durable and flexible due to multiple protective layers, contrary to the belief that they are fragile like glass. It is once somebody are getting the word fiber optics, they think that material is easy to be broken, like how glass can be broken. But fiber optics here, they say that in that the third sentence, they say that fiber optics is not easy to be broken like that, like the grass, due to their cables are made in the protective layers so that they cannot be broken easily as how you can think it can be broken. Let me finish by saying that fiber optic cable are delicate and easily damaged. In fact, those cables are designed to be robust. To be robust is to be strong and resilient. Resilient, you know, they must be made to be robust and resilient to have that satisfied or that needed protective or protection. Thanks a lot. I may invite Innocent to continue.
Good morning once again. So we are going to make summary of our presentation. So we started with an introduction about electrodynamic concepts and principles. Do you remember some of them? Yes? Some of the concepts you have been seeing about and the principles. What is principle? Anyone to tell us? Yes, tell us. Scenario zero. Other? Yes, Hilba.
It's about the
Total internal reflection in others. Yes, tell us. Framings, right hand. Yes. And we have seen about what a teacher needs in order to teach this concept. We have seen about the three things, if I remember. What is
pedagogy.
pedagogy? Adam, yes?
No,
About the content, others? Thank you, class. And we have seen about the optical communication system, what about is it, and the materials to teach it, and let us sum up with strategies of teaching this concept. We have seen about which concept group discussion and tell us another strategies. Yes, Gordon? Increase present learning. Yes, class? Huh? Simulation, others. Yes, Jado?
I have heard about the visualization.
Visualization. And last one is anyone to tell us the last. Fabrice, tell us the last. Okay, thank you. Yes, Janvier.
the last is
5 is instruction. Clap for yourselves. Thank you very much.
Flowers.